Every season brings the sky a unique set of constellations to view in the evenings.
Peering south in the winter brings Orion the Hunter. Spring brings Leo the Lion. Summer displays Scorpius the Scorpion. Finally, the autumn heralds into the sky the winged horse of Pegasus.
Year after year, season after season, the stars of the southern sky repeat this pattern. But as the southern stars rise and set with every new season, the sky to the north does not.
The stars in the northern sky remain all year round. They follow the rotation of the seasons, but never leave the sky. Famous star patterns like the Big Dipper, Draco the Dragon, and Cassiopeia the Queen simply appear to orbit around the star Polaris, the North Star.
From North America, the sky can be said to have two parts. The part that is changing, we see to the south, and the part that is permanent, we see to the north. However, logic would hint that if there is a portion of the sky we always see, there should be a portion of the sky we never see.
Stars are everywhere, in all directions. This includes, in our case, down. One rarely contemplates that if we could see through our planet Earth, we would see stars both below our feet as well as above our heads. This leads us to discover the third portion of the sky we don't see.
Saying there is a portion we don't see doesn't mean nobody can see it. The reason we can't is because of the position of North America on the Earth. The equator surrounds the Earth exactly between the North and South poles. Mathematically, the North Pole is 90 degrees above the equator, and the South Pole is 90 degrees below. Living in North America means that we must live between 7 and 72 degrees above the equator. This averages to roughly 40 degrees. This dot thus represents a position in North America. Let's add a line roughly representing a horizon. Everything above the line is visible to us. Everything below is obstructed by Earth itself. Then recall that the Earth is turning. 12 hours later, the Earth would have rotated us to here. If we look at the two positions together and extrapolate it for all times of the day and even year, we notice that there is a portion of the sky that is seen at all times, a portion seen only part of the time, and a portion that is never visible. Now, if we lived further north, notice how more of the sky is always seen, less of the sky is changing, and more of the sky is never visible. Inversely, if we lived further south, less of the sky is always seen, more of the sky is changing, and there is also a smaller portion that is never visible. Residents of the North Pole always see the same stars and never see the other half, whereas residents of the equator can see all stars seasonally. With this understanding, to see the sky we can't see requires us to move. We're going to head south of the equator and visit the Karoo Highlands in South Africa, where the South African Astronomical Observatory lies, and will give us the best view of the sky we don't see.
As we gaze into the night sky here in South Africa, not everything will be unknown to us. In fact, many of the constellations we see in North America are present in Africa, only upside down. For example, here is North America in December. Notice how Orion and his dogs are showcased. Notice them now in South Africa. The same familiar shape, only upside down. Here is North America in June, showing off the scorpion. The bug is flipped onto his back in South Africa. Let's recall the portion of the sky in the northern hemisphere that we see all year around. The north portion, the Big Dipper and Draco the Dragon. Where are they in South Africa? They can't be seen. For residents of South Africa, the Big Dipper and all its neighbors are never seen above the horizon. Instead, they have their own version of a sky seen all year round. This is the same area we don't see from North America at all. One major difference between the northern circumpolar sky and the southern is that there is no South Star. Northerners have the one star, Polaris, that's found in the same spot regardless of time or date. Southern Hemisphere residents do not have the again. If they did have a South Star, it would need to be located here. As time advances, notice how all the stars of the South seem to rotate around this point. Without a star here, what do Southern Hemisphere navigators use to orient here?
Like we do in the north, they use nearby constellations to help find south. In the north, we use the popular star pattern of the Big Dipper. Two of the stars making up the bowl can be connected and extended to point directly at Polaris, the North Star. Since the Big Dipper is very bright and easy to find, the North Star is as well. In the south, they use the constellation of Crux, the Cross. As a whole, Crux looks like a small kite, but a cross is easily formed by connecting opposite stars together. Once done, picture the longer portion of the cross extending downwards. This brings us very close to where the South Star would be. Of course, this entire process requires one to find Crux in the first place. Crux is the smallest constellation of the entire sky, only taking up this much of the sky. A specific method is used to find this small constellation. Draw your attention to the brightest stars in the area, here and here. This is the star Rigel Kentaurus, better known as Alpha Centauri. And this is the star named Hadar, better known as Beta Centauri. Alpha Centauri may sound familiar because its system is our closest neighbor. If our star, the Sun, was in danger of exploding and we needed to find another star to relocate, the stars in this system would be our closest options at a mere 4.3 light-years away. Where in galactic view, 4.3 light-years is next to nothing, from our point of view as humans, 4.3 light-years is an unconceivable distance for our minds and an unachievable distance with our current technology. A 747 aircraft traveling at 500 miles per hour would take over 5.8 million years to travel to Alpha Centauri. The New Horizon probe traveled the 3 billion miles to dwarf planet Pluto in 9.5 years, giving it an average velocity of nearly 36,000 miles per hour. Sending New Horizon to Alpha Centauri would require just under 82,000 years. Finding the Centauri pair is easily done by any skygazer in the southern hemisphere because of how bright they appear in the sky. Once they are found, draw a line from the brighter alpha to the dimmer beta, and then keep going. This will guide to Crux, which will then lead to the absent South Star. Where Alpha Centauri is bright, it isn't the brightest in the southern hemisphere sky. That title belongs to Canopus. Canopus is the second brightest star in all the sky and resides in the constellation Carina, the Keel. Carina is one of 3 modern-day constellations that once formed the ancient constellation of Argo Novis, the ship Jason and the Argonauts sailed in to search for the Golden Fleece. 2 other constellations form the sail, Vela, and the stern, Puppis. Where Alpha Centauri is bright because of its proximity to us, Canopus is just sheer brilliant. Its intrinsic luminosity is nearly 15,000 times that of our Sun. If it were 4.3 light-years away, as is Alpha Centauri, Canopus would provide nearly as much light as a full moon, and likely be visible in the daytime. But at 316 light-years away, Canopus rests as the second brightest nighttime star, only behind Sirius.
In addition to housing the second and third brightest stars in the skies, the southern hemisphere also houses a handful of birds. Of the 88 total constellations, 9 of them represent birds. 5 of them are clustered together in the southern hemisphere. Grus the crane, Phoenix the phoenix, Tucana the toucan, Pavo the peacock, and Apis the bird of paradise. Pointing our telescopes at the constellation of Tucana reveals a wonder of deep space that can only be seen from the southern hemisphere. This is the Small Magellanic Cloud, a dwarf irregular galaxy near the Milky Way. It is speculated that it was once a barred spiral galaxy that was disrupted by the Milky Way to become somewhat irregular. Nearby in the constellations of Dorado the Swordfish and Mensa the Table Mountain, its larger companion galaxy, called the Large Magellanic Cloud, can be found. The Magellanic Clouds have both had their shapes distorted by gravitational interactions with the Milky Way. In turn, these galaxies have also misshaped the outer bars of our own galaxy. The Milky Way is consuming gas that is flowing from the Magellanic Clouds in what is called the Magellanic Stream. Eventually, these 2 smaller galaxies might collide with the Milky Way. Both the large and small Magellanic Clouds have star-forming regions. One such region is highly visible here, the Tarantula Nebula. The Tarantula Nebula is an extremely luminous non-stellar object. Its luminosity is so great that if it were as close to Earth as the Orion Nebula, which is 100 times closer, the Tarantula Nebula would cast shadows. It is the most active and largest starburst region known in the local group of galaxies.
Speaking of our galaxy, the southern hemisphere has a far better view of our own Milky Way than we do in the north. The best portion of the Milky Way to view is in the directions of Scorpius and Sagittarius. In the northern hemisphere, these are seen in the summer, but both reside very low in the sky, not ideal for observing. In the southern hemisphere, both Scorpius and Sagittarius are far higher in the sky, giving far better vision of the center of our galaxy.
The Milky Way is our spiral galaxy, but we view it from its inside. In the Milky Way, the Sun is located right here, just about halfway from the middle and the outer edge. During June and the surrounding months, the Earth will be on this side of our Sun, meaning, at night, we're facing Scorpius and Sagittarius, which are in the same direction as the center of our galaxy. This is why the Milky Way appears bigger and brighter in this part of the sky than anywhere else. We're essentially looking through 75% of our galaxy.
During the December months, the Earth is on the other side of the Sun. This now points our night times away from the center. Now, we're only seeing 25% of the galaxy, and the Milky Way appears far fainter. Following this simple logic, we are more likely to find deep space objects when looking towards the center than looking towards the outside. Observatories located in the southern hemisphere are ideal for viewing such objects, as they're angled towards the center during the proper months. Take, for example, the telescope in Springbrook, Queensland, Australia, which is controlled remotely from the National Astronomical Research Institute of Thailand. Because of its perfect location in the southern hemisphere, it has provided us views of the heavens as we've never seen before.
The before-mentioned Small and Large Magellanic Clouds with the Tarantula Nebula.
The Lagoon Nebula, a giant emission nebula.
The Trifid Nebula, an unusual combination of an open cluster of stars, an emission nebula, a reflection nebula, and a dark nebula that cause the trifficated appearance.
The Helix Nebula, a planetary nebula formed by an intermediate or lower mass star shedding its outer layers near the end of its evolution. This has frequently been called the Eye of God.
The Rho Ophiuchi Cloud Complex, a dark nebula of gas and dust. This region is collapsing under its own gravity to form new stars. The star Rho Ophiuchi is embedded in the dust cloud, and its light produces a blue reflection nebula.
Centaurus A galaxy. The center of this galaxy contains a supermassive black hole with a mass equivalent to 55 million solar masses, which ejects jets of X-ray and radio wavelengths.
The sky we don't see is full of countless stars, fascinating constellations, and the finest view of deep space objects. The greatest aspect that gives the sky life, however, are the stories. Millennia worth of knowledge in constellations and stars have been passed on for generations through stories. Each culture harbors their own and may differ greatly from others. The Southern Hemisphere mythologies may differ the most from our own, because, remember, they see the stars upside down than we do. The same constellation will have a completely different appearance, and an even more different story attached to it. Let's look at the constellation Orion the Hunter, as we see it in North America. This large constellation is dominated by 4 bright stars in a rectangle shape. Each of the top 2 stars represent the hunter's shoulders. The bottom 2 represent his knees. Centered in the rectangle, 3 stars in a row represent his belt adorned across his waist. Hanging from his belt is his sword, seen as a faint line of 3 stars below the belt. To the west is another constellation that, in some mythology, forms an animal for Orion to fight. Taurus the bull. The bull is easily found by extending the line drawn from Orion's belt westward. This leads you to the bright star Aldebaran, the eye of the bull. The head is represented with the V shape of stars, and the long horns extend up from this V. Slightly further west of the bull is a small cluster of stars called the Pleiades. To North America, each visible star represents a sister, and as legends have it, there were 7. Looking at these same stars, but in Africa, and referring to African star lore, tells a completely different story. The Pleiades were the daughters of the sky god. When their husband, Aldebaran, shot his arrow, Orion's sword, at the 3 zebras, Orion's belt, it fell short. He dared not return home because he had killed no game, and he dared not retrieve his arrow because the fierce lion, one of Orion's shoulder stars, sat watching the zebras. What the skies of both the northern and southern hemisphere have alike are their usage as a calendar by our ancient ancestors. In the northern hemisphere, each season can be predicted by a glance into the evening sky. Orion beckons winter. Leo brings spring. Scorpius announces summer. And Pegasus heralds in the autumn. For the southern hemisphere, these same 4 constellations can be used, but the seasons are reversed. Orion is a beacon of summer, while Scorpius announces winter. Alpha and Beta Centauri and the Southern Cross help find south, as we saw earlier. But these stars were often referred to as the giraffes. In October, the giraffes would skim above the trees on the evening horizon. African residents called this tukwa, or rising above the trees. This was a reminder to finish planting their crops, as October for them is the middle of their spring season. The daughters of the Pleiades also marked the growing season. Called Hushseti, or the rain stars, they were first seen in the spring and stopped making their appearance in late summer.
"67% of the Earth's landmass and 88% of the world's human population live in the northern hemisphere. Many of the tools we use, like maps and globes, make north the default direction. Our sky contains a North Star that lies very near to the celestial pole.
Despite all that, we mustn't ignore the wonders that are in the southern hemisphere. The beautiful bright stars, the numerous deep space objects, and the incredible stories tied to the constellations calls us to remember the sky we don't see